or you'll allow me not to do my video today. Where I am is a bit hot, and yeah, not in a proper to do video. So again, I think we're already live. Thank you. And for those who are going to be following this up on YouTube, you can always ask anything. I'll just post it. I'll post it. I'll post everything as required. So okay, so let us get onto this. Let me see. I don't know if I can log into my brand account. Switch account. Then I go to my account. Sorry. So let me just sort these things out on the YouTube so that I can also okay. So let me just, for a moment, to avoid, because I don't have Willie on the call, let me just disable the waiting room. Okay, and that will make it easy for people to join in, for those who are supposed to join in. And the next thing, I need to take this link, the YouTube link, put it somewhere on my side so that I can check if there's any chats coming through. But since I'm not doing it totally live, so okay, awesome. So let me share my screen. Let me see, I have so many things open. So somebody is asking that blocked out. Kindly join in. Oh, is it Ramadan? Are you here? You're there, right? Yes,
Yeah,
I think
yeah,
Ramadan.
yeah.
Oh, good. Okay, I've disabled the waiting room to make it easy for people to join in. And now, time to share my screen, and we get onto this thing. We enjoy the hands-on. Okay, so okay, let me see which screen I'm supposed to share. Good. I'll not share my whole screen for purposes, for reasons best known to me, because I have so many things open. So let me log in to my Academy platform. Then I go to LMS. Okay, you can confirm that you can see my screen. I would prefer you do these things audibly, because me checking the chat is okay. So you can see I've been accepted. I'll accept this. Accept this. So I was supposed to do this thing about early access, but I'll do it later, as I was telling you. So let me just leave it at that. So let me go to my cloud architecting. Cloud architecting educator. Are you seeing it? Yeah, it is. Awesome. So don't worry about the navigation to the platform. If you enroll to the course, you get a good deep dive on how you access all this. So my focus is on the hands-on, and the hands-on is converting a monolith application to a microservices to make it just more cloud native. So we're going to break down a monolithic. Okay. Did you just see it? Okay, where is it? Yeah, it is. It is a guided lab, which that means you're going to be shown step by step what I'll be doing. So you're going to convert a Node.js application into a microservices, which is very important. We are trying to move away from what we call lift and shift. We don't want to just lift things out of our on-premises onto the cloud. We just want to ensure that we take full advantage of all the good things that come with the cloud. And some of the things that come with the cloud is scalability, cost optimization, so that you gain all the benefits by making an application more cloud native. And one way of doing that is utilizing microservices. So it is loading. Let it load. Hopefully you can see this, and I hope I'm not going to be affected by network issues. Let me just put my phone on charge, which I'm using for my hotspot. Good. You didn't confirm for me whether you can see my screen. You can see it, right? Let me see whether it is appearing. It is appearing. I had the link. What happened? Oh, here it is. I want to see how it appears on YouTube. Okay, it is still at the loading part, which is fine. I need to confirm for me whether you can see my screen. You can see it, right? Good. That is there. So I'll hide the terminal because I don't need it right now. And then I'll start the lab so that it starts provisioning the resources. Then once that screen appears, I'll close it so that we can go through this. So it's starting. Is it starting it? Okay. I was waiting for this screen so that I can close it. I'll see whether it's ready in a few. So you can see what we're being told here. Traditional monolithic architectures can be difficult to scale, as I already told you. So what a monolithic architecture is, let me just do this and make it very easy for us to understand through a diagram. So I can write monolith versus microservices. You can see it already appears. Then I'll go to the images side. I hope ChatGPT would have made these things very easy for me, but let me just go through this. Which one looks the best? Okay. I think this one looks awesome. So it doesn't mean that monolithic applications are bad, but what is there is that there are different business considerations when you're deciding on what to use. So let me just use this diagram. Open image in new tab. Yes, so this is a good diagram. So you can see this is how a monolithic architecture application looks like. So you have the user interface, which you interact with, the business logic, as well as the data access layer. They're all tightly coupled together, and you have one single database. And most of the time, this is how we develop our applications. I remember if you are in campus and most of the time you're doing maybe you did an IT project, most probably you created a monolithic application. You had one database, you had some business logic and data access layers, and you had an interface, all them connecting, maybe through what we call XAMPP or WAMP or any kind of provisioning server, so that you can be able to do this maybe on a local machine. But most definitely, you are not able to do this at first. Why? Because of the complexity that comes with it. I remember when I was doing my cloud developer course, Udacity Nano degree, this topic almost made me give up on that whole nano degree because it was terribly, the learning curve is so steep when you've never done this, maybe in a real life scenario. But here we are, we survived and we were able to do it. We did it as a group. And later on, I came to realize it's a very good thing to also learn. But doesn't mean that it is either this or that. Certain business considerations would prefer you work on a monolithic architecture, and not all the complexity that comes with microservices might be too much for maybe a legacy application or a small startup that cannot manage doing a very microservice. Maybe the benefits that are going to come with a microservice application may not be that much compared to a monolithic for such an organization. So there are pros and cons for each, but as always in the cloud, the best utilization of the cloud is through a microservice architecture. So here you see what happens is, for example, what can think like what we did for a nano degree, we had like an Instagram lookalike application. So we had to break down that monolithic application where we had the image processing layer as a microservice, the login application or the login layer or the authorization layer as its own kind of an application. We also had the feed as an application by itself, like how the feed of the application. It was called Udagram. I think I don't know whether I can quickly run on to my GitHub, show you what we had. It had an explanation of that, but I think that it totally makes sense, and I don't want to waste a lot of time on it, but I'll share it maybe by the end of the session. I'll have shared. I'm seeing my network is still loading funny. I don't know whether I'm still clear or I'm breaking. If I'm breaking, you just tell me. Just make sure you tell me. I don't know whether why my internet is acting up. But you'll tell me. If I'm not, you can also tell me that I'm clear. But yeah, okay. Don't worry, I've not been active over the last 2 months, so don't crucify me on my contributions. So if I go to my repositories, if you see your diagram, you just tell me. So you can see this monolith to microservices project. Was it this one? Yes. So you can see we had an API feed for the user login, and we also had the front end, and we had something called a reverse proxy, which we did during that. And we were doing this all through an AWS environment. So you can still check it. It was a Node.js, and yeah, can post it for later consumption, and you can check what we did there. So let's get onto this. So I can see, I don't know whether my lab finished loading. Okay, I need to click on AWS, which is details. You can show. Let me just click on show so that I can confirm. So I can see everything is fine on this side. So we can see what we'll need to do. We'll migrate a monolithic Node.js to run in a Docker container. So who has an idea? Who has ever heard of Docker and knows what Docker is all about? You can just put it out on the chat, or you can just unmute and say what Docker is. Who has an idea in the call? If you have an idea of what Docker is, or if you've been using Docker. Anyone? As you tell me, if somebody is typing, the next thing is you're going to refactor the Node.js application from a monolithic design to a microservices architecture. So the first thing is you're going to just migrate it the way it is, and then you're going to refactor it, and then you're going to deploy now the containerized Node.js microservices to Amazon Elastic Container Services. So you can see the evolution of the application design as it moves from a monolith. So you can see everything, the user, the threads, the posts, like a message board service, all in one context. And then we're going to have a user's microservice, a threads service, and also a post service. So you're going to break down the three from the monolith to now the microservices. That is how it's going to be evolving. So you can see if one function here fails, the whole application fails in a monolithic. And the other thing that you need to note is each function in a microservice runs as a separate service, and it can be scaled up and updated independently of each other. So it makes it very easy to work. Wow, it says I need 3 hours. So what do I do? Okay, I'll see whether I can run it off and see whether you are going to do the migration and see. But 3 hours for me, I think it's too much. I'll see whether I can crack 1.5. So let's start off. So this is the is arranging. So what I need to do is, once I have my AWS console, I'll put this on this other side. I will also do that. I will close the courses. I don't know, what do I do here? What do I need to do to hide this? Let me see first. Oh yeah, it's this part. I need to hide that. What else? I need to do this. Yeah, I think it looks better. And I can see the instructions. This is my AWS management console on this other side. So let us start. So what do I need to do? To set up your development environment, you'll open AWS Cloud9 IDE, download and extract the required lab files. So I'll just open Cloud9. Cloud9 is like VS Code. So it's usually on AWS Cloud9. So there it is. Let me get a drink of water to be precise. Okay. Are you with me? Kindly confirm that you're with me. Hope I'm not on my own. Fabius, Tonga, Ramadan, hope you're good. Hope you're following it up on what we are actually going to achieve.
Yeah, we are good. You're good.
Ah, nice. Okay. So here always check on what you're being told. These are step by step. So in the Cloud9 IDE card, so this is the Cloud9 IDE card. Here it is. Choose Open IDE. I'll choose this one, right? So I'll click on that. The IDE opens in a new browser and displays several tabs, including a welcome tab. You're going to see that. The bottom pane of the IDE, enter the command in the terminal tab labeled bash IP just like maybe 192.168.0.1 or something. They're just giving a placeholder. So what does this command really do? So I'm going to, using curl, I'm going to download the lab files, and then I think I'm going to extract. So this command will be the output of this command will be the input of this command using this pipe, right? So let us run. So it needs to have an idea. So here it is, iBash IP. So I'll paste. So this is how the ID looks like. Let me just maximize so that you get an idea. So you can see it looks nearly like Visual Studio Code. So usually have the welcome tab. I can just close that out. I can just make this a bit bigger, run that command there. I can just allow, let's do the command. Very fast, done. And you can see they're here. 3 folders, containerized monolith, containerized microservices 1. We already have that. So let me just put it to the side. The command retrieves, you've already been told, and it has done that. It has downloaded and extracted it. We have that. So you can see the following folder, no container, contains the files that are related to the monolithic implementation of the application. And the implementation is intended to run directly on a Node.js server. So this one is no container. Then the second one is a containerized monolith. So what happens is it contains the files that are related to the monolithic implementation of the application. This implementation is intended to run in a containerized Docker environment orchestrated using Amazon ECS. So what I told you about Docker is, I usually love using these simple words. What is Docker? Just ask yourself. It's very hard. So it's just a platform designed to help developers build and share, run modern applications. Why? So you can just use it to to run applications. I remember the first time I used it, it hogged a lot of my space. It takes a lot of space. I don't know why, but it's a very good platform to just deploy applications. So always you can just check that out. Let's go back. Containerized microservices. Let's look at this. So this is where we want to reach. This is our main goal for the lab. We want to have the files that are related to microservice, the application, implementation of the application, and intended to run as well in a containerized Docker environment orchestrated using the Amazon Elastic Container Service. So keep the AWS Cloud9 tab opened throughout this lab because you're going to use it frequently. So we're going to have this tab open for quite a while. So let's run the application on a basic Node.js server. I think you're going to be following the first folder. So you can see this is the architecture. Let me just maximize this a bit. So let's look at this architecture. So we have the whole environment is within AWS Cloud9. You're going to have an EC2 instance. And within that EC2 instance, it has going to have two workers, like you're going to have the message board service with two workers and a cluster parent just to maybe distribute the HTTP request between the two workers. But you can see both of them are monolithic applications. And it will going to use the cluster functionality to spawn one worker process per CPU core. So if the EC2 instance has two CPU cores, can easily use it by using the cluster functionality. So you can see the processes share a single port and are invoked using what we call the round robin. So round robin is when you do one request, it's going to go to one worker. When you repeat the request, it's going to go to the other worker and going round and round and round. So that's why it's called the round robin by using what we call a load balancer, which is built into the Node.js. So it can increase scalability on servers that have multiple CPU cores. Remember, it is only one server. So you are going to install Node.js modules required. Then you're going to review the application design. Then you're going to just run the application. So let me put it back to the side. Hope there's still no one who is having an issue. I'm not seeing any issue. Okay, let me just hide my WhatsApp there. Okay, so let's get on to this. We looked at the architecture. Now we get to installing. So we are going to change our directory to the folder. So let's just do that right now. Okay, so let me just do a clear. Seeing I'm having a very dirty kind of, okay, I'm in that folder, this folder, the folder one, npm install KOA. Let me just reach out to someone here. Hello, sorry, I'm back. So let me just install this. It's installing that KOA router models. Don't worry about too much about that. We're just running this. We want to look at how we're going to do this. So I think these are Node.js modules. So we just need that. So you can see core.js is a widely used Node.js web application framework that facilitates building of what we call asynchronous server-side JavaScript applications. So that is the reason why you're installing it. So I think that is done. So if there are any kind of warnings and notices, you're going to just ignore them. But I have not seen any warnings. So sorry, just telling someone here to do something. Okay, so we're going to review the application design and code. So in the environment, we are going to expand this. So here we have a Node modules folder. I hope if you are familiar with Node.js, usually this is where you put the dependencies for the application. Usually have the Node underscore modules folder. So it usually contains the folder created when you install the required JavaScript modules. So, okay. And then what is next? db.json, we have a db. So this is a JSON object that simulates the database, and it contains the attributes that represent users, threads, and posts. So if you look at it, if I open it very fast, you can see that is how it looks. Users, threads, and posts. You can see that some 3 or so posts. Then we have the index.js. Here it is. If I open it, that is how it looks. So it is the application's entry point. As you already know how index really works, we have the package.json, describes the application, the entry point, and its dependency. So this usually is very important, the package.json. So you can see the dependency is core and the core router. The scripts to run is node index.js. So package lock is usually an automatically generated when you install the JavaScript modules. So it is used by the installation to track modifications made to that folder. So these are the package lock.json. Then you have the server.js. It usually defines the application's RESTful API methods. So if I open it, we're going to see some of the different methods. You can see we have API users and ID. So usually used for the RESTful API. And then we have the package.json. So you can see, you can just, so for the purposes of, you can see line through to 5, line 2 through to 5 on package 2 to 5. So it is these ones here. So you can see the dependencies that we installed are listed here. Line 6 to 8 has 2 to 5 is up to here, sorry. Then 6 to 8, we have the scripts and that. So we are going to examine the db.json object. Here it is, lines 2 through to 27. From 2 here, we have up to 27. Down here, I think here we have the users, right? The users. So we have like 4 sample users: Marceline, Finn Alberts, Paul Bariam, and Jake Storm. And then we also have threads. So we have, did you see the Brazil game, new French bakery, sample threads, in search of a new guitar. So do you see that? You can see these are threads. And then we have 47 through to 78, they're the posts. So we have some 6 sample message posts that are here. That last goal was awesome. Yes, the way the ball was served was what a talent. I have to try the attacks. I'm planning to stop by the morning. So you can see it is related to a thread and the text as well as the user. Think of it like a very primitive Facebook application, if I could call it. And then review the code for index.js in the environment. So you go to index.js, then 1 through to 3 is to import. So you can see you are doing some importations here. Going to import class HTTP and OS, which are very important modules. where is it? Line 3 is using the OS module to ask about the number of cores, CPU cores. So if it is 2, it's going to spin 3, 3 is going to spin 3 workers. If it is 2, it's going to spin 2 workers, like that, to spawn or to spin it, whichever one works. And then lastly, review the code for server.js. Server.js, here is where we were. So line 16 through 19, I think I just jumped some things here. 5 through to 15 is the one that is run the first time. It's called the leader thread, like 16 to 19. So you can just, if you're coming through to the course, you can have more time to analyze the code. But let me not do the analyzing first. But it's very important for us to look at the server.js, and especially lines 13 through to 47. So you can see you're going to have like get API users, which will return the collection of users in the database, information of a certain user, API users user ID. If you're not familiar with APIs, it's very important to get to understand what APIs. Think of it now like sockets. You have different sockets in your house. We have a socket where you connect maybe your cooker. The same socket that you use with your cooker is not the one that you can use for your laptop. You have a different type of socket. So they just help you to get access to power. So think of it like that. So we have the threads as well as the specific thread, and then certain posts. Post in thread ID returns the collection of post messages for the thread that is identified by the thread ID. So all the posts regarding to a certain thread ID through this API call, and then returns the collection of post messages for the user identified. So if a certain user has been making certain posts, you can be able to just check that. And then you have the API without any kind of specification. It returns the message API ready to receive requests. And then at the root, returns the message ready to receive requests. And 52 defines the port number where the application listens to requests. So let's look at that port number. It's going to listen on port 3000. Good. Okay. So we're going to run the application. So we're going to run npm start. So very, very fast, npm start. So we can see leader that is running, worker, that number is started. So I've seen that the server is started and the application entry index.js is run. The first time that index.js is invoked, it creates 2 cluster threads, leader and worker, to process the request. So next you leave the current terminal and active and open a second terminal tab to test the application's RESTful API. So I'm going to just do a terminal here, new terminal. In the right terminal tab, so I'm going to retrieve the API users resource by running that, because the application is already running. So you can see it's giving me something, but it's not that well formatted. But you can see it returns the JSON object that returns the list of users in the message board. So I can see Marceline, I can see Finn Albert somewhere, I can see Paul Bariam, Jigstorm, here they are. Select the left terminal tab. So how many tabs was I supposed to open? I think it's only one. So let's go on. We're going to look at another call. So we are going to look at which was that one that was crazy. I think we're going to now go to this one. We're going to look at one user, the fourth user. So let's just run that. It's a very easy kind of so what do we get here? Do you see? I think you can see the command, the result of the command is here. So we have username is Jake. Jake Storm is a soccer fan and a skydiver. Okay. What else? I need to go and retrieve the threads. So I can see all the threads are here. And then retrieve all the posts for the first thread. So let's look at the posts that are related to thread 1, thread with ID 1. It's telling me my network is unstable. Am I audible? Okay. Gitonga, Ramadan, I'm good. Hope I'm good.
Yeah, you're good.
Okay, thank you. Thank you for the confirmation. It's very important. Okay, so look at where I am. Thread 1. Thread 1 has the last goal was awesome. It was done by user 4. Yes, the way the ball was served, what a talent. It was done by user 2. So I think I get the gist of this. So do you see what we just done? Stop the Node.js server in the left terminal by pressing Control-C. You have validated the application is ready. It responds properly to GET request. In the next, you'll containerize the application. So we need to containerize. So this one was just running directly on Node with no container. So it is still a monolithic application, but we are now going to move from it being just a direct application to now a containerized monolith. So we're going to prepare the application for Docker containerization. Then we're going to provision a repository. Then we're going to build and push a Docker image to the repository. So let's do the first part of Docker containerization. Allow me to just like 10 seconds just to confirm something. Okay, so where are we? Okay, here we are. So we are now to first doing this first part, preparing the application for Docker containerization. So what will we be doing in this step? We are going to put that application into a Docker container. And then for that to happen, you're going to remove the use of the node.js cluster feature and convert the application into a single process design. And then with Docker containers, the goal is to run a single process per container instead of the cluster of processes. So we're going to create what we call a Docker file, which is very important. And then you're going to, which is going to be used to build a script that contains the instructions how to build the container image of the application. So a container ready version of the application is provided to you on folder 2. This folder 2. If I just do this and I just expand that and I look at folder 2 and see, open the package.json. So let me just do this. Let me maximize and clean up all this. So let me just close this tab. I need to Control-C here. I've closed that. So I'll not close that tab, but let me close all these files from folder 1. And then I now take it back to the side. So what am I being told here? I'm being told to open the package, the JSON under folder 2, as you can see that. And then I'm being told to examine what? Line 7. And notice that the entry point of the application was changed from index.js to server.js. So what happens? Let me just open the other package.json. So here we have the other one. So you can see here the entry point is node index.js. But here, do you see the difference? Node server.js. This is in the no container folder, and this one is in the containerized monolith. So you can see that is where we start. The differences start. Then The index.js contains the initialization logic for the cluster feature, but we're not going to use that feature. Then in the environment, we're going to expand that, open the server.js in an editor by double clicking it. So we're going to open server.js. Here we have it. The only difference from the non-containerized version is line 54. Is there line 54? Which brings the worker, the message worker, states message worker started when the application is first started. Worker started. Let me see. Worker start. Are you seeing that? Did I open the right server? Oh yeah, I opened the server.js for no container. So let me just open the server.js for the containerized. And I'm sure I'm going to get now the line 54. You can see console.log worker.started. This one is not available here. You can see. So I was wondering why am I making a mistake? So this one is the one for no container. As you can see, if I hover, you can see that is the folder, no container. And this one is containerized. So let me close that one. I've seen what we have seen in line step number 23. Then going to step 24. In the environment window, you're going to expand that and open the Docker file in an editor by double clicking it. So Docker file, here it is. And then we're going to see it contains instruction on how to build the container image. This contains the instruction. So from mhat/alpine node 7, so we're going to use, I think, node 7.10.10.1. So you're going to do what? So you can see the base image where the container will be built is alpine node, which is a node.js image. So line 3, what happens in line 3? It's going to set the working directory to be /srv. And then line 4 is going to add the contents of the containerized. So you can see the contents, usually use these 2 dots, to the current working directory that is /srv, which is set in the previous line. So it's going to take everything that is here to everything to /srv. And then line 5, which is very important to know because of containerization. Line 5 is going to invoke the npm install command to install the applications, library, and dependencies that were declared in the package.json. In our package.json, we declared the KOA and the KOA router. So there we are. And then line 7, let's go back to our Docker file. Line 7 is going to expose the port 3000 so that it can, the container is going to listen when it runs. Then it's going to ask, line 8 is going to ask Docker to run the command node server j.js, which starts the application when the image is started. Now that we understand how the container image for the application will be built, now examine where to put the image after it has been built. So we're going to provision a repository. Remember, we had 3 things to do. We're going to prepare the application, then you're going to provision, then you're going to build and push the Docker image to the repository. So let's see how you're going to provision the repository. For the sake of time, I will avoid reading all this through, but always remember that Amazon AWS has a service called Amazon ECR, which is the Elastic Container Repository, which is integrated together with the Elastic Container Service. So usually you need a repository so that you can be able to store our images for sharing and version control. So you can think of ECR like the way you can think about GitHub. Think of it like a GitHub for containers. So we're going to go to container in your environments browser tab. Wow, your environments. Where is my environments? Is it under Cloud9? Okay, let me just do this. Yeah, it is here, my environments. choose services. Where's the services? Oh, yeah, sorry. I'm supposed to do this. I thought it is something inside there. Then I'm just going to look at ECR. Container registry. Then you're going to create a repository, just get started. You're going to call it MB repo. So let's open this. So this is what happens in a day-to-day basis for a cloud developer. You need to know how to help a customer move from on-premise to the cloud, and you need to help them maybe break down a monolithic application into a microservices, which is something that with time, if you do a lot of practice, you do a number of projects, it becomes a walk in the park. So let's click on get started. Repository name, we're going to write that. I think you haven't been told whether you want to make it private or public, so just going to leave it at defaults. Then I'm going to choose create repository. You can leave all the other parts in their defaults. So you don't close the window that shows the message, fine. We'll use it in the next subtask. So building and pushing the Docker image. So you're now doing the last part of this subtask. Is now, remember, we are on the step where we want to containerize the monolithic application. That is the big picture. So we are at the third step. So before you can successfully run the next steps, you must upgrade the AWS CLI. To do this, you go to the Cloud9 IDE in the left terminal and enter the following commands. So you're going to install AWS CLI. Then you're going to export the path to home, So let's just run these commands. I'm going to switch the path. The path is going to be, so you're going to maybe initialize the path environment variable with the home, which is usually under another variable, as well as now also together to be path. So it's just something like an initialization. So I think I can do clear here. I don't know whether it's going to work. Yes, so it's clean. Let's run these two commands. The comments already up to date, okay. So that is done. Let me put my, so it is done. So yes, what has been done. So go back to ECR. Message window at the top, choose view push commands. View push commands. And then for MB repo open, so Windows list for CLI commands customized for the repo. And they are purposely built to authenticate your Docker client to your Amazon ECR, build your Docker image, tag your Docker image, and push your Docker image to the repository. So it has two versions, the Mac OS or Linux and the Windows. First, you'll copy the run command to log into a Docker client to your registry. So let's do the first one. So you copy this and run it here. So it's just about to log in. So you can see login has succeeded. Beautiful. The next thing in the pop-up window, locate the first command and then copy. I think you've already done this. Enter. I think you've already done that. And then you're going to see login succeeded, which is fine. Then in the terminal tab, change the directory to containerized monolith, which is fine. Totally understandable why we need to move from there. So we have changed clear my commands so I can see it's a cleaner. Okay, there we. So it'll allow me to do this so that I can show you it's a cleaner. So here is where with the commands. So we are at now, our current folder is this one, right? Okay. Switch, okay. Switch to ECR console browser, push commands for the MB repo, locate the second command and copy the command. So the command looks like docker build t, the tag is MB repo into the current. So it is here. We run it. So make sure you have the period at the end of the command. So you can see this happening. Some things are crazily happening. So it is running npm install. So sometimes when you are doing this command in our Udacity Nano degree, it was crazy. It would fail at a certain step and you have to wonder what really happens. But I can see here, AWS Academy made this very easy for you. You just run them, they work. For us, certain commands would not work. You have to look at the dependencies and you have to survive until you get to the end. They are saying errors are there to make your skin tougher. So I think we're done. So you're going to see successfully built, and you can see that there's a number there, a special number, and it's successfully tagged to MB repo latest. So it has the latest tag. So, okay, next you'll tag the image repository URI so that it can be pushed to the repository. So switch to the Amazon, the commands, push commands, locate the third command, choose the copy icon. So you're about to tag. So this is the third command. So docker tag. So let's do the tagging. Awesome. So the tagging has happened. It's just easy. Tagging is just putting a label. Okay. So where are we? So let us go on. Ramadan. So where are we? In the terminal tab, run the copied command. So I think we've already done the tagging. This we have already done. The push command, locate the fourth command. So what is the fourth command? This is that. So let us look at the fourth command. The fourth command is what? To push this image to your newly created AWS. So you're going to push the image to the repository. So you can see the pushing is happening. It happens very fast. At our times, it usually used to be crazily slow for the other project. So there we are. We have already pushed. Switch to the Amazon. Choose the MB repo. In the repository, close the command. So we're going to close these commands. So let me just maximize this. I close the commands and then I go to, do you see what has happened? So do you see I've already created it. It happened at some 7 minutes ago. So that is fine. Okay, record the image URI in the images list and locate the image URI in the latest version. Click copy icon. So images. So you think this is the image URI. So I can maybe quickly open Notepad, paste it there, just for purposes of having it there. Let's take it back to the side. Okay, what is happening next? So I think it is now in the ECR. in the Elastic Container Repository. Now we need to deploy the monolith to ECS, the Elastic Container Service. So you can see this. Let me maximize this one. Let me also maximize. It's making it very difficult for me to maximize. Yeah, I've been able to crack it. So let's look at what is happening here before I go to maximize. So look at this, just look at this architecture of the containerized monolithic application. Remember the other one had a cluster for within the one instance. So you can see this, there's going to be a load, an elastic load balancer. And then on the target group, you're going to have 2 EC2 instances, each of them having the monolithic application, and all of them having working through the MB ECS service and the task definition, and all these within the container image ECR repository. So you can see this is going to be within a VPC. Our VPC is going to be of 10.32.0.0/16. So you remember the other one was just within Cloud9, but this one you're doing it within a VPC because you're having more resources. You're having a load balancer, you're having 2 EC2 instances, you're having a target group, and you can see when a browser client makes a request, it's going to go through the first point it's going to hit is the load balancer. So the steps that you performed in this task, you created an Amazon ECS cluster, you created a task definition for the container image, you create that you're going to be doing, then you're going to create an application load balancer, then you're going to deploy the monolithic application as an ECS service, then you're going to test the containerized monolithic application that it works. The same way we did the testing when it had no container. So let us take this back to the side. And then now let us go to what? Now let us go to the next stage. So where's the next stage? Where's the next stage? Where's the next stage? I think we did these ones, right? These ones, we did them. Now deploying. So you already looked at that architecture. You already looked at these are 1, 2, 3, 4, 5 tasks that you're going to do. So task 4.1, creating the ECS cluster. So you're going to go to ECS. So you can just do search. Then I write ECS. Here it is. So let it load. And then you're going to go to clusters. Then you're going to create a cluster. So really what a cluster does in our diagram. Let's look at what it does. So you can see where does the cluster sit? So you're going to have, you can see the cluster is going to hold these two. It's like you think of it like a not a bucket, a container for. No, let me not call it a container. Let me call it like. Can I call it? I'm about to say kikapu and I'm wondering how to say that without. Let's think of it like a shopping cart for the containers. So now the cluster is a logical grouping of EC2 instances where you can run. So you can think of it like a grouping of instances. So that represent your status and services that run. So we're going to create a cluster. So the cluster enables you to create all the infrastructure that are needed, that the VPC, the subnets, the security groups, the internet gateway, the IAM roles, all that are going to be created within the cluster wizard. So here we are. So go to clusters, you can see clusters. Then I'm going to go create cluster. And then I'm going to say in the select cluster template page, select EC2 Linux plus networking. Did I see that? Select cluster template. Okay, maybe in this new definition is not clear. So this is the name, MBEBS cluster. First of all, did you see this select cluster image? Just confirm. Let me just maximize. I don't think I'm seeing that. Okay, okay, it's the new experience maybe. Okay, so MBECS cluster provisioning model is on-demand instance. So I'm seeing infrastructure. So I think this one is going to confuse me. I don't know whether I switch to the old experience. Let me see if I use the old console. Yeah, I think this one is better. And see, select the cluster template page, EC2 Linux plus networking. So I can just choose this one. And see, now I get that. I get to next step. Provisioning model on demand instance, which is fine. Cluster name, I pasted it, there it is. EC2 instance type is going to be t2.micro. Number of instances, I just need 2. VPC, create a new VPC. You can see that. CIDR block is 10.32.0.0/16. Very important to know about subnetting. And you're going to look at 10.32. So here it's just using 32. Then you're going to say 32. So you can see that you're being told 10.0 is not within the range. You're going to sort that. So yeah, create a new security group, which is fine. Security inbound, leave it as the default, which allows inbound to port data. The message in the container instance says that you are not, they're granting permission to ECS to create the ECS instance role. This role authorizes it to invoke, which is fine. So you can see this is a message, create a new role, ECS, which is fine. We're leaving it at that. Then I'm going to choose create. So this is the old experience, but it is the one that I think was still being used when you're making this lab. So you can see creating CloudFormation stack resources. So it is also taking advantage of, so a cluster has been created and is IAM policy has been also attached so that it can be able to do what all these about the resources of the cluster. And I think it's also finishing on that. So we're waiting for this part to finish. And so you see what is happening. The route table is still pending. VP virtual private gateway attachment, the auto scaling group is also pending. So you can see the only thing that is now left is now the auto scaling group. So I choose view cluster, shows a value of active, and then choose the ECS instances tab. So it is finishing. I think it is done with the auto scaling. So I think we're done. You can see the 3 steps are done. So I'll click on view cluster. And then I can go to the EC2 in ECS instances. And I can see shows so I'm supposed to refresh here. So it's going to take a bit of while for me to see them, but I can see one of them has appeared. Wow, which is nice. So maybe another one will appear in a few. So I'm expecting a second one. So you can see, wow, good. I now have my 2 instances that I required. So they are there. So you can see, as you can see under all or under active, I'm seeing the 2 of them. Choose the task tab. So under this tasks tab, no tasks are deployed for this cluster. So you're going to create the one. So let's create a task definition. So basically what a task definition is just some of the configuration on how to run the Docker container on ECS. So think of it like what container image to run, how much CPU and memory will be needed, and what ports the container will listen traffic on. So we're going to choose the task definitions. So it is here. Create a new task definition. Select the launch type compatibility, choose EC2 card. So I'm going to choose EC2. And then I think I'm supposed to go to next. Yeah, next step. Configure tasks, then configure the configure tasks definition opens, the MB task. And then we're going to go to scroll down to container definitions. So do you need a role? Let me just scroll. Let me leave it at that. Container definitions. Here we are. I can say add a container, configure, call it MB container. So you realize like you're using MB and you're just changing some of the URI. Then where are we? So we're going to paste the image URI. You remember we copied it to our notepad. There it is. So I'm going to copy that. And then I'm going to have it there. And then memory limit, select a hard limit of 256. So this is going to be a hard limit of 256 MB for the memory. That is, the container is going to be allowed to use. Think of it like the way you usually put some hard limit on PHP, php.ini settings or something. Then port mappings is the container port. Remember, we used to use 3000. So container port, I'm going to put 3000. I do not need to enter value in the host port. So protocol remains as TCP, which is fine. So it should look like that, and you can see that and that. So you can see it looks similar like mine. Then I'll choose add. Remember, I'm still doing the container definition. Then we're still doing the process of creating a task definition. Then scroll down and we do create again. Don't worry about the error. Sometimes it's because of the account type. These are a practice account, not a production kind of an account, AWS account that is. So the task definition has been created successfully. Then you're going to now create the application load balancer. So ECS console, choose compute, choose services, compute EC2. So you're just going to go to EC2 and create the load balancer from the EC2 console. So we are at the EC2 console, it is loading. So I think we are moving on well. I told you I'm just going to need, I think, 1.5 hours to do this. out the video and see what I've been doing, and maybe ask, well, what did he really do? What was he doing on this part and that part and that part? And always you can reach out and see what I've just done. So it is loading. So we are about to create the load balancer. Remember, the first thing we did in the lab is we examined the application when it had no container. This second step, we are now creating the monolith application to be containerized. Then we're going to examine how it works. Then finally, we're going to break that monolith into a microservice, and now also make sure that it works, which will now mark the end of our lab. So we're going to create a load balancer. So we're going to load balancers, usually somewhere down here under load balancing. And then you're going to choose create a load balancer. So I'm going to use an application, usually have a gateway and even the classic and even the network load balancer. But this case, because you're dealing with layer, is it layer 7? Yes. We want to have a load balancer that is aware of the protocols at that level. So you can see it's going to deal with HTTP and HTTPS traffic. So let's go to create MB load balancer, which is quite interesting. So it's a very good practice to call your to name your resources according to what it is. If it's a load balancer, you call it that. Okay, VPC, you're going to use the one that has the 10.32 so that you make sure that you're within the same VPC. So this one, you just jump, don't go to the default one. So you're going to use this one. Remember, you don't leave it at 172, don't use the Cloud9 VPC, use the 10.32. And then availability zones, you're going to select both of them, the US East 1A and the US East 1-2. You can just leave the subnets the way they are. Then you're going to configure the security settings. So you can ignore the warning that your load balancer is not using a secure listener and choose next. Choose next. So security group, you're just leaving it at layer. Configure security groups. Here we are. Cindy, that is where we are. So I'll clear the default one. Then I'll select the EC2 container service MB ECS cluster ECS. I think this one is the long story short, it is just that one, not the default one. So this is the security group for our ECS cluster. And why are we doing this? The reason why you're doing this is because we want to ensure that the load balancer is also going to be in security as the ECS, cluster. If you look at the diagram, if you look at back, you're going to see that line that shows where it should be. And then we have now going to configure the routing. So we're going to use a new target group. You want the wizard to create a new target group for the load balancer. So you're going to call it the MB load balancer target group. You remember there was a target group. A target group really helps just to show that where do you want the traffic to go to? Where are you targeting this traffic to go? Which kind of instances or something like that? So instances, I'm sure target group name is that. Protocol and port, you can just leave the way they are. Threshold, the healthy threshold. So advanced health check settings, so you just expand this. So these are some of the things under CloudWatch, if I'm not wrong. So it does a health check. So it will need to check an instance twice before it marks it as unhealthy, or maybe considering an unhealthy target healthy. So it has to check at least 2 times, as you can see. And then, so you can see as you're being told, it tells the load balancer the The target is considered healthy if it receives 2 consecutive successful health checks from it. Then interval 6, which increases the frequency of health checks to once every 6 seconds. So you can see it is 30 seconds, so you can just reduce it to 6 seconds, which is going to increase the frequency. Then you're going to register the targets. So we're going to next. So the target is who? The ECS service as a target. So we're going to use, can skip because you'll register an ECS service. So you're going to not use the available instances, just skip this part. So I'm just going to, is there anything? Review, then you create target group. So it is MB load balancer is now in the load balancer. Wait a few moments. So I'm going to refresh under load balancer.
Yes. Poa poa
What's
sana.
happening? What's happening? Amedrop ama
Sijui nini imehappen, sijui sijui Leka ameenda wapi.
sawa. Hello. Hello. As ana communicate, ana share screen akifanya akikey in the commands ama ni on my side yenye view hizo commands akikey ama anaongea tu.
Mimi sijaona hizo commands mahali
Because anasema it's working, but no, inashindwa whether ni mimi sioni akikey ama something.
Yeah, hadi mimi sijaona, so maybe
Anasoma tu.
Yeah, hebu tutamuuliza akirudi.
Sawa.
Yeah.
Sorry, I'm back. Sorry, somebody called me and it affected my network, and I'm back. Sorry for those who missed that. So where was I? Let me just share my screen. Hopefully I'm not going to share anything sensitive. So confirm that you can hear me, Gitonga and Ramadan.
Yes, we can hear you.
Okay, thank you.
Yeah,
Thank you
sure.
for sticking in. So we are about to move. We are moving. So what is happening? Why is it telling me to launch terminal? Let me just launch it. Then let me maximize this. Just usually a strategy to avoid Zoom. And then what will I do? I don't want to refresh this part. Okay, I'll have to refresh the whole page. I want to avoid this part, return launch terminal. I think it affected my network a bit, but let me just refresh. I'm sure I'm going to get the whole picture. So so far so good. Hopefully, I hope it is as interesting as you're getting it. And as always, you can ping me. You just prepare your questions. You're going to have like 5 or 10 minutes after the lab, so that we see. It has taken longer than I thought, but I'm sure it is. Sometimes things happen. I didn't know it is a 3-hour lab, which obviously I usually do it in lesser time, because at least I know where things are in the AWS console. Don't tell me it's going to load forever. Anyways, so you're supposed to now, after you've done the target, as it closes, you are supposed to now select it here. If you refresh, do you see you find it here? Here it is. So let's just confirm that we are on, I think, step. Which step are we? Yeah, we have done that. And then you're going to register the targets. I think we've done. We're going to redo that. It's now in the load balancer. Wait, refresh to complete in the description. Scroll down, SG. It is load security to copy the security group ID to the clipboard. So I need to do this security group ID for what? So to complete, so I'll have to finish first of all. Next, skip the register targets. I think I don't need to register any targets. So next, review, and I create the load balancer. And then I should view. And then I should see it is provisioning. Under status, I can see it is provisioning. I'll refresh, it doesn't take too long. So let's wait a bit. So basically what a load balancer will really do, it's going to be the interface between the client. It's going to provide a URL. And it's going to be transferring traffic across the instances. If there's one healthy instance, it's going to report that it is unhealthy. And then a new instance is going to be spawned into that cluster. So this provision is taking a bit of time, but we can be checking the next steps. So we're going to look at the security group. And then we're going to copy that security group. We're going to use it in the subsequent step. In the inbound roles, we're going to change the inbound roles, and then we're going to add a TCP, a custom TCP rule. And then you're going to add the following configuration. The port range is going to be 31,000 to 61,000. And then you're going to say the source is custom. Then you're going to paste the security group ID from the clipboard, which is fine. So okay, now it's active. Awesome. So I can click on the load balancer. I go to security. I get the security. Let me just maximize. I might be missing something. Nothing is missing here. Oh, security. Here's the security group. Let me take it back to the side. So security group ID, here it is. Let me take it to my notepad. There it is. And then the bottom page, select the inbound rules. So edit inbound rules. So I'm going to edit the inbound rules for this security group. Then I'm going to add a rule. And then I'm going to have it as custom TCP. So let me just maximize for you to see how it usually looks like. So this is how the inbound rules page looks like when you've maximized it. Custom TCP, our port range was 31,000 to 61,000. So 31,000 to 61,000. And then since it's custom, you're going to type the security group ID, paste them in, and then you have it like that. And so what really this is happening is you're going to allow TCP traffic into the security group for the ECS service, for the ECS, and through that security group. So that security group is the allowance. Everything within that is going to be in that. So we have that ready. Take it back to the side. Now we have already done this part. So you should be able to see custom TCP rule. Oh, I was supposed to call it custom TCP rule. No, I think here it is, right? Okay. So deploying the monolith as an ECS service. So you're going to go to that. Is it this one? I think we moved away. So let's go to ECS. And then you go to task definitions. Then you're going to choose the MB task list. And then you're going to say from the actions, you're going to create a service. Okay, let's get to that point. Oh, I didn't click on it. Wow. ECS. Open it up, close that as it loads. So what am I doing here? I'm actually using the task definition to create a service. So go to task definitions, choose the MB task link, select MB. I'm going to select that. Then under actions, I just say create a service. And the launch type, I'm going to say EC2. And then service name, I'm going to use MB ECS service. So I'm too lazy saving to type. It's too late in the day to be typing that. So service type is going to be replica, which is fine, it is there. And then number of tasks will be 1. So normally to take full advantage of the cluster, you would enter a higher number depending on the request load that you expect. However, keeping things simple for this exercise is fine. And then you're going to choose the next step, and then you're going to configure the network. So let me maximize for you to just have an idea. So here you don't have to change anything next step. So network, I think it's the application load balancer. Let us just confirm here. application log IAM role. So you need the roles just for the load balancer to assume these roles. So you're going to see role, create new role, which is going to be like that, MB load balancer, container name and port. I think it's fine. The correct information. Then production listener port is 80. Should I see that? I think I should see that. Production listener port. Is it in the next step? I think it might be in the next step. So it is saying please configure container. This is already populated MB load balancer. It's fine. Production listener port. How am I supposed to change that? Target group name is going to be MB load balancer target group. I'm going to choose the next step. Okay. So I say add load balancer. Oh yeah, production listener port, I can see that. HTTP. I think that is fine. The other thing is fine. Target group name MB load balancer target group, which is fine. Good. Now makes sense. So the container which is going to be load balance is this one. And yeah, let's move on. So service auto scaling, are we supposed to change anything here? Next step, set auto scaling to optional. In the step 3.
Gitonga, we just end this meeting.
Can't we just wait for him so that asijipate peke yake kwa meeting?
Okay, okay.
And you draw the suggestion around that one.
I'll try.
Oh, Kevin is back on.
Another. So let's look at what happened here. I don't whether it finished. Let me just refresh. Don't think. Oh, my
Your audio.
screen share is loading. It's telling me
Your
it is
audio.
loading. I
Your
don't know whether
audio.
it is already loaded. Is it
Your
loaded?
audio is kind of breaking up.
My audio is breaking.
Your audio is kind of breaking up. Yep.
Is my audio breaking?
Okay.
Okay. But I'm hearing you clearly. I don't know. Share again, then I refresh, then I share again. Is it now clearer?
Yeah, sure. Yeah, it's good on my end.
Okay, I think my network is now finishing up. So okay, it's telling me I have to go back. No, I can't go back to creating it. So what I need to do, I need to go to ECS. So where was I supposed to check? I'm going to have to check on service. So I'm going to check on ECS. Let me check on ECS. So we are about to finish up. You can see when our scrolling is moving. So I'm going to just test the containerized monolith. Once you are done. So I'm going to task definitions. Then I'm going to look at the time B task one. So it says I have to go to the load balance. I'm not going to be able to see the services. Okay, let's do this. Let's get the load balancer link and see whether it's going to show us able to receive requests. Life is going to be easy for us. I'm not going to stress. So let's look at the load balancer. This is the DNS for the load balancer. Open it up. It's not going to load. It shows that I didn't finish the service process. It's telling me it took too long to respond. We just put the load balancer somewhere. Link. So do we repeat the process? Do we repeat the process? I think we should. Let's go to MB task. So am I audible? Don't know. I'm saying this thing is loading a lot. And I don't know if it's my network acting up.
Yeah, you're audible.
Okay. Sorry, I'm back. So I'm back. Let me see. Let me do actions. Date service. I said there are no services. So it means that there was no service that was created. So let me just go to action, create service. And then I was supposed to do EC2, MBECS cluster. I think it was MBECS service. But let me just check. Maximize this. Then I go to this part. MBECS service, yes. Of tasks is going to be 1. Next step is going to be MB load balancer, create a new role. Okay, I think that one, I know, I understand this part. So let me just do this part like test. And I'm going to just, once I put the name, number of tasks is going to be 1. Is going to use an application load balancer. The load balancer name is going to be MB load balancer. I'm going to add to the load balancer that one. I'm going to use HTTP. The target group is going to be the MB load balancer target group. And then I'm going to go to the next step. This one I'm supposed to just leave it the way it is. Once I review, I'm going to create the service. So you can see the IAM service role has been created. The policy is about to be created. My NED 3, but I don't know. I think I might be still on the way. Then the service has been created. Awesome. So when I go to view service, I'm seeing it's active. So if I refresh, I might hope that I'm going to get the right call. Also, the last status, it is pending. So what am I supposed to do? So let's maximize this. Oh, sorry, just maximize the wrong thing. Minimize that. Let's maximize this and see launch status view until I see it running here. So after a few moments, choose it. So that I'll see. So let's maximize this. So do I think, wait, where should I refresh? Oh yeah, I've seen the other part. So you can see it is running. Awesome. So let us see whether if I refresh this, you're going to see something. still not getting there. So let's see. It says it's going to take a bit of time. Let me see. It's telling me that I'm going to need to do this again. Hopefully I'm not using HTTPS, which is not going to work. HTTP. I need to use HTTP for now because I don't have the SSL certificates. Let me see. I'm seeing establishing a secure connection, which is not going to work. HTTP. So let it wait to load. So I should be able to see that when I see /users, I'll be able to see that. When I see /1, I should be able to see that. So it means that now the monolith is now working as a containerized monolith. Why errors? Why errors? Which step? And it's very hard to know which step we missed, but it's because of maybe network or something. All right, am I supposed to be using? Am I using the right thing? Okay, let me just open this. Because I'm saying it is active, it's going to be running. Configure service discovery. I didn't see this step. Okay, let's see. Let me reload one more time. And also I'll see at the security group level. I think that is where things usually go down, not in a not good way. In an ungood way. And here it is. Inbound rule 8, which is fine. It's going to allow custom TCP. Let me just do this so that life becomes easy for me. Let me see whether it's going to be any IPv4 and see. Oh, let me just delete this and add another role. Do a 31,000 to 61,000. And then we just use any IPv4 and see what happens. So let's see whether that is going to help. If that was where the issue is. The other way to know is when I can look at the target group and see whether everything is healthy. As a target, so I can see it is here. The ECS cluster. So if I open this, the one that ends with 9A0, 9A0, and that ends with 9A0, this one. So if I select it, I decide to go directly behind the load balancer and see what happens. It has a refuse to connect. Let me look at its security group. Let's see whether I can do a bit of manipulation. So I can see security group is this one. Inbound rows, heated TCP 00. Now I edit the inbound rows. The inbound rows. Let me delete this one that I did. Then I take it back to be I use the security group ID, which is this. Then I run it against that. And then I'll save those rows. Let's try again. So let's look at this other instance. This one is the Cloud9 ID instance, so I don't need it. I might need this one. Oh yeah, the other thing is it might be going directly to HTTPS. Is it really allowing it? I'm really wondering why it is saying refuse to connect. And it is using the security group for ECS, which allows 8 TCP. Oh, 8 protocol, it should be HTTP. This is where the issue is. This is where the issue then is. It's HTTP. So it's fine. It's not an issue. HTTP 80 from anywhere. Let me add another role and let me just say HTTP. Let me just do this and see how it usually goes. Sometimes these security groups might be having issues. Then I just say all, and then I say anywhere IPv4, just to make things easy for us because this is a lab, it's not a production. And see other things to work out. Let's go to the other one first. Go to the load balancer. So you're having issues with the target, with the loading of the load balancer. I don't know whether you missed a step because every other thing is fine. So the other place we can run a reachability analyzer. So let's go to monitoring and see. Okay, don't think we need monitoring. We might need to see the network mapping. Is fine. Let's go to the listeners. HTTP. It is fine. Is the A record. So if I paste it, maybe just use another new browser, new incognito window. I paste it. Maybe specify a HTTP. See, it's going to load. Okay. Go to the target groups. My checks are fine. Targets are healthy, which is one. See, it's in 31,000 to 61,000. It is in that range. Oh yeah, that could be the other issue. Let me go back to the security group. And I go to the EC2. Inbound rules. Edit inbound rules. So this one is not going to really help. Now I'm going to add a rule. I'm going to use the custom. Let me start with the HTTP one, which is usually the easier one. Then obviously I put it on anywhere IPv4. Then I add another rule. I do the custom TCP, 31,000 to 61,000. Then this one I use the SG. This one, I save the rules. I wonder what these other rules are doing. Let me see, they might be related to something that we need. So this one is allowing all traffic. This one is also allowing all traffic. To this one. This one is also allowing all traffic. Okay. Okay. Minimize that. Then I'll maximize this. Let's see if I missed something here. So I'm saying I did something that had 3 steps and this one had 4 steps. I don't know whether that had an issue. Create configure service discovery, MBCS, EC2, and all these processes. Let me see if I redo the process of creating the service, I'm going to get something. So let's see how we can do that. So I go to ECS. Yeah. Let me delete this service. Then I'm going to go to task definitions. Then I'm going to go to this task. And I select this, I go to actions, create service, MBS, MBCS service, replica number 1. Looking at it. I think this one was not supposed to be changed. Let me just confirm if there's anything that I needed to change just before I go to the next page. Replica number, and then you go to configure network. So the issue might be here under configure the network. What is happening? Don't tell me my network is then again acting up. Oh, launch type EC2. Next step, application load balancer. And then ECS server. That is the one. That is the one. Going to add to the load balancer. We're going to use that. Then target group is going to be the load balancer. Yeah, so this is the other part that I saw. didn't see how they put that. Let me just put 10 seconds, going to hopefully. So service policy. At I'm seeing 3 here, so it means that there must be something. It's creating the private DNS namespace. Okay, all this has been done. Oh, this service is still draining. Previous. Where do you give it the name? I think it's the previous. So if I give it a new name, let's see whether it's going to work. And then the service created. Good. So let's view the service. Then we wait for it a bit. Still activating. That was the issue, was the service discovery. They didn't put it in the what? They didn't put it in the lab steps. Good, now it's running. But at least we get the point. Let me see whether we can move to that steps first. Although I'm sure I'm not going to get the full mark for this. So let's see what are the other steps to refactor. I'll just jump all that. So I think I need to review provisioning. So I'll now create a repository. So I'm going to create a repository called MB users and MB threads and MB posts. Let's see whether I'm going to go. This monolith has decided to do something on us, but we're going to go to the other step. Let's go to this. Going to go to ECI. I'm going to create 3 repos, a repo for users, a repo for threads, and a repo for posts. So let's do that fast enough. So let's create the repos. that MB users, MB threads, and MB posts. Then go back to Cloud9. I still have my Cloud9 working. So what I'm going to do is I think I'm going to push three images. I'm going to build. So let's go to our Cloud ID. So we start with CD. I'm going to build that service. Then we're going to build and push the post service. Then I'm going to deploy. This is how they look like after the deployment. I'm going to have a target group for each. Create a task definition for user. Create a task definition for threads. Create a task definition for posts. Then we're going to configure the load balancer. I'm going to create a target group for each of them. Then I'm going to create listener roles for the load balancer. Oh, this was quite something. Then go to deploy. Create an ECS service, another ECS service, and then another. Then I'm going to validate the deployment. Oh, then I'm going to get to the end. So just wanted to get the big picture. So am I just here somewhere? Then let's see. Clear. I'm going to Docker build. I'm going to target the latest. Oh, okay. So go to MB users. MB save your push commands. I choose the second command. I use this one, right? Tagging has happened. So this one has a problem. Then I do the push command by using the fourth command. If I'm going to miss any step, the pushing is happening, and I'm done. I think the pushing has done. And then in the images list, I should see that. So I should close this. Then should go to repositories. Just refresh. Be users repo. I'm seeing the images here with the latest tag latest, which is fine. I repeat the step for threads very fast. Repeat the step for threads. So I'm clear, just make it clean. I CD to the threads folder. I'm there. I go to this side, I say view push commands for let's go to I view the commands for what? For threads. Say Docker build. So that is, as that is running, I can choose the second command to tag. Tagging has been done. And then I can do the push the image. That has been done. And then I go to the posts. So I CD to the posts very fast and easy peasy. I do this. I go to posts. And then I go to the commands for posts. So I close that. I go to posts. Say view push commands. I first with the build. I'll clear that. I'll do the build. Once I do the build, I'll do the tag, then I'll do the push. Build tag push. Tagging, and I push it. Okay. I think I'm done with this. Now you're now deploying. So we're going to create a task definition for each. We're going to configure the application load balancer. Now going to deploy the microservices as ECS services. Then you're going to validate, then you're done. So task definition for each task definition. So I'm going to go to ECR. So let's see. So going to be using MB users task, MB users container, limit 3000. There's something I'm missing. I'm not getting it. Is it in ECR or ECS? Yeah, it's in ECS. That is where the mistake is. You can see here. They're saying ECR console, but it should be ECS console. Because where did we do task definitions on the other part? Let's see where we did. Yeah, we did it in ECS, not ECR. So this is a mistake. It should be ECS, not ECR. So how are we? So you can see is where you did the task definition. So I'll do this side by side. I'll refresh this. We are in step number 192. So let me refresh this so that I can hide this terminal. Just refresh so that I can just have that place to hide the terminal. Then I go to step 192. So this one was bigger than I thought. I'm going to finish there. Yes, Gitonga, you want to drop off? You can ask. You can unmute. I'm not hearing you.
Okay, I had written something on the charts because your screen is not shared, so I can't even follow along.
Okay. Sorry. Sorry, I think I missed that. Don't know how long I had not shared my screen, but it's fine. I'm going to later on repeat this whole monolith to microservices again, just to make sure that we don't have any errors on the way, so that you can also do it on your side. I don't know that are you enrolled for AWS Academy and you have this?
No. I hadn't enrolled.
You haven't done you haven't done a course with me, which you should be able to do one course with me. I'm going to open up for cloud foundations and cloud architecting, I think tomorrow is February, right?
Yeah.
Yes, I'm going to start off I usually have some Saturday early morning AWS sessions that I usually run, I think once every 2 to 3 months. Every 5 weeks, I do like something for 5 weeks, then I rest for like a month, then I do it again. So I'll do that. But let's now try to follow along and finish this. I usually say we finish what we start. We don't give up on the way. So we are in step 192. I hope you can now see the screen.
Yeah, sure.
So we are in step 192. So what I just did maybe I was not sharing the screen, I just created repositories, and then I did these commands of docker push, docker tag, and everything. So those are not too hard things to do. They're just copying and pasting commands. So I'm going to the ECS. So ECS is here. I'm going to task definition. So I'm creating a task definition for each of the microservices. So users. So I'm going to call it MB users task. EC2. I think I have to go to the next step. Let me see if I can push this. I can just do that. So this is where I was, 95, 190. MB users task. So I'm going to call it MB users task. Like that. Sorry, I've just copied a command instead of the name. MB users task. And then I'm doing that. And then the task role. Task role is going to be what? Scroll to the container definitions. So this one, I think I was leaving it. Yeah, I was going to container definition, then container name, MB users container. Image URI. I need to get the image URI. Wow. So what I need to do, I'll have to open. Just put this like that. I'll have to open a new ECR where the repository is, and get the what, and get the image URI so that I can paste it there. It's totally fine. So let's see whether I'll open it up. Where is our repository? We are under the repositories. So you're looking at the MB users repo, the image URI. You can see I can just copy URI here. I can just put them all down here, but I don't even need to do that because I'll just scroll to each and every one of them. So let me just not even do that. So I need to put the image URI there. Hard limit of 256. Port mappings, I think the container port is, I think, where we are dealing with. Let's look at it. It is the container port of 3000. And then I think I choose add. Add. And then I scroll down and I choose create. And I do the same for threads. I go back to task definition. I create a new task definition. EC2, next step. I call it MB threads task. And then task role, this one I was skipping that. I go to task container definition. And then I call it MB threads container. The threads image URI. Where just go back to repositories, threads image URI is here. I get it, I post it there. This will also be the issue when true private registers. Okay, let me just leave it as that. 256. What else do I do? The container port of 3000. Then I think I'm done with that. I add Anything else I need to do? Scroll down, go back and create. Then I do the last one, create a new task definition. C2. I go to the next step. Just copy the names, be post task. Scroll down, add, call it MB post container. URI tag, we get it for the posts. Posts, go in, get the image URI, paste it there. Hard limit of 256. Container port 3000. Add it, scroll down, and create the task definition. So we have done that, the 3. Then you're going to configure the load balancer, creating a target group in compute EC2, create target group, specify. So let's go to the target group in the EC2. I think it is on here, target groups. Create target group. We'll call it that. VPC should be the one with 10.32. The threshold is 2. So this is under here. The threshold is 2. Interval is 6 seconds. And I choose next. And then I register the targets. In step 2, choose a target. Create target group. So these are users, right? Okay. So I need to repeat the same step, create target group. Then I go to the threads. I'm still using the other VPC, the 1032. Yeah. Health checks should be 2. Interval should be 6. I think I should go to next. Then I should create. Then I go for the post. I repeat the same process. I create the VPC. Then I choose it, call it BLB posts group. And then I post that. And then the advanced health check settings. Threshold is 2. Interval is 6. I go to next. And then I go to create. Creating listener roles. Open the details for MB load balancer. MB load balancer. So I finish with the target groups. I go to the load balancer. MB load balancer. View edit roles. The line. In the line, I should see viewer edit rules. Did I see viewer edit rules? Nope. Let's go to it. Manage rows. Hello. Okay, let me finish up. So I'm being asked even to go for supper. So where are we? So I'm adding the rules so you can see. So here we're going to have different rules. You know, create a new rule to forward the request to the users if the request URI matches that. So in the toolbar, add rules. So I'll add that. A rules box appears, allowing to add if. So add if. So if then, so add condition path. If the value is API users, the path is that, then forward to users. Yeah, then click save. Then threads. Then save. Then you add another one. The condition path. Posts. What is posts? Add action forward to posts. Let me see. Let's looking at it. Users, threads, posts. We are done. Then you click save. There was a configure if add. There was the line below row 3 and condition if the value is that or value is /API forward to the users. Then I click on save. The rule is added as a rule 4 in the basic toolbar, the toolbox. Choose the edit rules. Scroll to the last rule and choose edit rule. Then delete. In the rules editor, configure the setting, then delete. Which one am I deleting? So I'm creating an ECS. This is the process of creating an ECS service. Return to the load balancer back. So There's one that I need to delete. Scroll to the Rust rule, choose edit, then delete the existing one. And return a fixed response. Then response code should be 200. And then should be invalid requests. Okay. I think that is update. Then I think we are now deploying the ECS services. Create an ECS service. So I go to EC2 ECS. So I think ECS is somewhere here. Here it is. And the clusters, choose MB ECS cluster. Wow, 240 plus steps. I think I didn't open it up. So, I don't have even clusters. Monique, yes, it should be ECS. The Kubernetes service, the container service, the native one for Amazon. So I'm seeing the MB ACS cluster. Then I go to services tab, then I go to create. Task definition. Family. MB users task. Service name, MB users ECS service. Service type replica, number of tasks 1. Next, configure the network. And then I'm going to use ALB. Oh, I need to have chosen EC2 here. ALB. And then ECS service role, MB load balancer, add to load balancer, HTTP 80. Target group. Target group is MBL users. And then next step, you do not want to configure, review, create service. Good. Next, create service. How many steps are here? Okay, why are they 2? Anyways. So we do the same for threads, then we do the same for posts, then we see, and we're done. So the only thing I need from threads is this. The rest I know. So create EC2 threads task. That number of tasks is going to be 1. There's nothing else there. Application load balancer, threads container, to load balancer, HTTP. This one is the target group, right? For is this threads? Yes, it is threads. Starting to get a bit. And then I'm going to the last one. Create EC2. There's posts. Is it posts? Yes. Post ECS. That number of tasks should be 1. The other thing I think is the next step. LB. I think it should be fine. Load balancer. Target group is the post target group. Then we go to the next step. Next step. We create the service. So I think we've created the 3 services. 3 ACS services. Should be finishing up. Good. So I should be able to see 4 active services, which are their post threads and users. So I'm going to validate in the services list, select MBACS service. This one, I think I called it 2. And then choose update. For the number of tasks, we put 0. Skip to review. I think this one even had an issue. Yeah, and I think I'm done. Load balancer. Should be ready to receive. Then /users. So we try to do that. Let's see whether now that you've refactored, our life will work out. The way it is loading forever might not work out, but we've done everything. Next, retrieve, post and press enter. Post microservices returns a JSON. So I really wish this DNS load balancer would actually load all these services. So it must be a reachability issue, which I'm going to look at, but I've done everything. Already converted it. And let's see if I submit my work, how much marks I'm going to get before you close it. So I know there's the issue of the reachability of the ALB. Let's see if I submit, how much they're going to, the system is going to give me for that lab. Go to grades. So it was out of 80, but let's see how much I'm going to get. It's generating the report. I'm going to check whether I configured, I did this. So you can see I have everything. I got all the marks. So where was I missing the point? I've gotten all the marks, which shows that the ELB. So let's just check one last time whether I got the URL for the load balancer correct. I think that's where the issue is, but I know that I did everything perfectly. So let's go to the instance EC2, then we go to load balancers. So internally it might be working. So this is the load balancer. I don't know if it is prepending an HTTP request. Let me use something like Firefox. Oh yeah, the other way I can be able to do it, even if the DNS is not working, is using Cloud9. So let's do that very fast. How was we doing it on Cloud9? Let me remind myself, where is the Cloud9? Where is the Cloud9? Oh, Cloud9 is here. So you remember there's a command we ran here. So we did that, and then we did that, then we did an install, then we did a tag. The place where it was giving us some commands. Yeah, I think that would help us. Oh, I remember it was a new terminal. Should I call it or should I what? Yeah, you can see ready to receive requests. So it is working. And also if I do a call on slash API ready to receive requests. So you can see it is working. It is beautiful. It is working. So if I do API users, you see I get all the users, although I don't get it that well. If I try, I think if I use Postman, it would still work. So it must be an issue with the rendering on a browser or something. So no worries. That's not a big issue since I've gotten all. So if I just do maybe a new basic HTTP requests, then I say, okay, I'll update later. I say MB load balancer. So I don't know if it's going to run it. So a basic GET request is not coming through because of a timeout, but a call request is working. So it must be an issue under HTTP and everything. Should be an HTTP issue. So because it is timing out under that. So slash API. Still not going to work, but I'm sure it's not going to work because of the same of the browser. But you can see that one would work. think the other one that we were giving was thread. Is it threads? Yes, you can see it is working. So that is fine. So since we did it, yay, 2 hours, or is it 3 hours later? Surely, maybe they said it's going to take 3 hours, and surely it has taken 3 hours. But you can see I've gotten all the marks according to the system. It has done a testing report that all the parts are working, all the things that I did. And yeah, maybe I can do a screenshot of this mapping tool just to tell the people decided not to stick on to the end like you, that we did it. Yep, so I can save that for another day. And I can put it under my AWS collection. So I think that is that. I know we can't have time for questions, Gitonga, but I hope you saw how the process is, but we're going to look at why we could not do it on the browser. But I think you can see that we've been able to do all the things. We were able to start with what? With looking at the no container Node.js application. Then we looked at how we can containerize the monolithic application. Then we broke down the monolithic application into 3 microservices. Now that was the users, the posts, and the threads. And able to run it all through. There are different target groups, there are different task definitions, there are different services, and even maybe the different clusters. So this one, some of the labs that are there in our AWS Academy. So you can see if I open more modules. I'm still finishing up on my cloud architecting, but you can see there's so many labs. There's so many labs that you can do. Even a challenge lab, so you can see there's a guided lab, then a challenge lab that has no guidance. So you try to do your thing on yourself. Some guided lab and some challenge lab apart from the normal learning. So that is a lot that you can digest, but the good thing is you can even get a badge and a completion certificate and also a discount on your solutions architect associate exam. Although I was able to pass the exam without finishing this course and many others. But yeah, so I think that is basically it. Unless there's anything, we're going to have a much cleaner session, if I can call it cleaner, when we start out the sessions. Hope that was nice. Thanks so much for sticking through. You gave me the motivation to finish 300 plus. I think it is one of the longest labs I've ever done in this course. I think I still have some few to go. I don't know, let me just check my grades. So I have my capstone project. I need to finish that, but I haven't finished it. I haven't done the knowledge check for module 9. I haven't done the challenge lab for automating infrastructure deployment. And then I need to do some 2 knowledge checks. Then I think I'll be done. So I think I have some 3 knowledge checks, 1 guided lab, and I think 1 challenge lab, if I'm not wrong. A capstone is not requirement, but I prefer to finish it. A capstone project is very good, gives you a real life scenario. So yeah, hope that is it. That is nice. So you can see these are some of the other cohorts I've ever done. If I go to courses, so you can see I've ever done some cloud foundation cohorts, cloud security foundations. We have a learner lab for you to do some practice. We have data analytics. We have so many things there. And I can see I've been given some early access review for a project, which I will do that later. So that said, I think have a lovely night, Gitong. Hope it was a nice one.
Yeah, same to you. Same
Okay,
to
thank you. We'll be in touch. Okay, thank you so much.
Sure.
Okay, let me end the stream. I'll copy the link and I'll share that. Okay.